Good morning and welcome to the study guide review for Unit 4. This is the study guide given on Thursday, February 14th for the Unit 4 test, Friday, February 15th. Please remember to study for the test tomorrow. Study guide problem number 1. Using the following exponent rules, simplify the following. So you have your exponent rules still a sheet that was given to you back during the review, and it's also on Google Classroom as a PDF. You can take any variable term which is in the denominator, and you are going to move that into the numerator. And when you move it from the denominator into the numerator, you're going to change the sign from positive to negative. This is now x to the negative 18 over 1, essentially. So now this is in the numerator. Means the number on top is the numerator, the number on the bottom of a fraction is the denominator. Here the rule says if you're multiplying, which is happening in the numerator, the base number is 7. We have an exponent of 5 and 4. So since we're multiplying, we're going to add the exponents together. And in the denominator, we have 7 to the negative 4. Let's simplify this a little bit more. We have 7 to the 9th over 7 to the negative 4. You have two options now. One option is to subtract the exponents. Since you have the base numbers are 7, you can subtract 9 minus negative 4. So your answer is 7 to the 13th power, because when you have two negatives, it's the same as making it plus. Another option you would have is to take that 7 to the negative 4, which is in the denominator, and you can move it up to the numerator. And now I can add those together. 9 plus 4. And you have the same answer, 7 to the 13th power. That number is too large to evaluate using a calculator, so leave it simplified like that. These are the same base numbers. They're being multiplied, so what are we going to do with the exponents? We're going to add the exponents. The first exponent is negative 3, plus we need to add negative 6. I'm using parentheses here, so I keep the symbols straight. Now you have access to a calculator, but even using mental math, negative 3 plus another negative 6 is negative 9. If I owe $3 plus I owe $6 more, I'm going to owe $9. Base numbers on D are the same. So we're going to keep the base as 5. The rule says to add the exponents, and we end up with 5 to the 9th. And on part E, we have, similar to C, we have 9 in the numerator, 3 plus, there's 1, 9, 1 plus 4. In the denominator, we have 9 to the 10th power. I'm going to add 3 plus 1 plus 4. I end up with 4 plus 4 is 8. 9 to the 8 over 9 to the 10th. Now I have the same base number, and I'm going to subtract 8 minus 10. My final answer is 9 to the negative 2. I could write that as, I'm going to move over here, 9 to the negative 2. You can stop there, or you could write it as 1 over 9 squared, or 1 over 81. Please refer back to the paper that was passed out that reviewed lessons 1-2 to 1-5 in your notes. Problem 2, convert the following into scientific notation. Well, when we do this, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to change that to 6.72. Remember, the leading number has to be between 1 and 10. Or another way to write it is 1 is, x is going to be greater than 1, or 1 is less than x, and less than 10. Now, it can't equal 10, but it can equal 1. So we're going to put a little equal sign there. We need to count how many zeros. This number is very small, so we've subtracted. We made this number big by a lot of factors of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is a small number. You're going to have a negative exponent. B is a very large number, so we're going to move this decimal point from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got to move it over there. 1.234 times 10. Oh, I forgot. 3, 6, 9, 12. Positive 12 because it's very large. C is also very large. We're going to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4.56 times 10 to the 11th. We have a small number for D. 1, 2, 3, 4. Again, I'm moving it so that I create a number between 1 and 10. And I've moved it 1, 2, 3, 4 spots. It's small, so it's -4. Number 3, convert the following into standard notation. Now we're doing the opposite of putting things into scientific notation. We're going to take them out of scientific notation. 10 to the 9th power is a very large number. Okay, so we're going to write 8 and then 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we have, this would be the millions place. This is the billions place. So it's 8 times 1 billion. So what is this number? This 10 to the 9th represents 10 times 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10s. Okay, and that's how the decimal system works, and that's how scientific notation works. When you're multiplying by a set of 10s, in this case 10 to the 9th, you're multiplying by 1 billion. This is -4. So how would 10 to the -4 work? Think about your rules of exponents. Isn't that 1 over 10 to the 4th, which is 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10, or that's 100, 1,000, 1 over 10,000. Now let's look at what happens when we move this decimal point. We have the 5. It was here. We're going to move 1, 2, 3, 4. Put it there. We have 0.0005. Another way to say this number, that's the tenths place. Hundreds, thousands, 10,000s. 5 10,000s. And look over here. Look at this number. That's the 1 over 10,000, and we have 10,000s over there. So we're keeping it all consistent. We're learning number sense. We're doing really good. Now we have it's a little easier with the positive. We're going to move this decimal point to the right to make a much larger number. We're multiplying by 10 times 10 times 10 times 10 times 10 times 10 times 10. So we have 7 and a 4. Now that's moved the decimal spot 1 time. We need to move it 6 more times. 1, 2, 3, 4, 5, 6. Put some commas in there. And it's 74 million. Problem 4. Determine which numbers are irrational and rational. If you look here, I've added from your notes on Tuesday, Wednesday, I gave you a handout. You need to really get that out. You can have it during the test. This is a great Venn diagram. And when you look at the Venn diagram, you can see that we have overlapping circles. So natural numbers belong into the middle circle, which means that natural numbers are also whole numbers. They're also integers and rational numbers. So when you get to the whole numbers, we add the number 0. So it's whole natural numbers plus 0 are whole numbers. And then integers are all those numbers plus the negatives for integers. And then the rest of the rational numbers are made up of fractions, terminating decimals, the negative fractions, percentages that terminate, and again, another terminating decimal. Anything, a rational number can always be written as a fraction a over b. Irrational numbers are all the rest. Things that never terminate, like pi, which is 3.14, etc., etc. A decimal that doesn't terminate, and radicals like square root of 3, square root of 5 that never terminate. So we're looking at which ones are rational, irrational, and rational. The square root of 9 is equal to 3, so that's rational. 1/4 is written as a fraction, a over b, so that's a rational. This number, does it have a pattern? 413, 413, 413, so it is repeating. If it has a repeating pattern, it can be rewritten as a rational number. Pardon me. The square root of 6 is irrational. It's a non-terminating number. So it fits into this category. Same thing with the square root of 10. You can use your calculator to calculate this. If I use my calculator and I turn it on and clear it all, I put a square root symbol and 6 and hit enter, I get the number 2.44948, and it keeps going on, but there's no pattern. There's no pattern. It is a non-terminating. If you have those, if you have no pattern, non-terminating, you are irrational. So the same thing with square root of 10. I'm going to test it with my calculator. The square root of 10 equals 3.162277, and it keeps going. There's no pattern. Irrational. Pi is irrational. You can use your calculator. You can push pi, the button pi, and hit equals, and it's irrational. Just because you multiply it by 2 doesn't make it rational. It's 2 pi is still irrational. And then looking for a pattern here, we have 0.232, 424, 2578, no pattern. So what do you guess? It's irrational for H. Problem 5, order the following from greatest to least. Now this is 10 to the 8th, and this is 10 to the 7th. This number has to be much larger. Let's put them all in scientific notation really quickly. If I count 3, 6, 8, that's 7.2 times 10 to the 8th. If I compare that to the first number, this number is larger than number 1. So we already know out of the A, B, and C, A, B, C, we know that C is larger. D, it's times 10 to the 9th, so it's larger by the A, B, and C by a factor of 10. And let's put this in scientific notation. 3.1, let's count 3, 6, 8. We have another one times 10 to the 8th, but it is smaller than C, and it's smaller than A. So we know now, so far, D is the largest or greatest. Okay, let's look at this F. It's times 10 to the 8th, so for sure, D is the largest. So let's write largest or greatest. And then way over here, we're going to put least. My spelling is a little bit off. Let me erase that. And rewrite it L-E-A-S-T, least. So the greatest number we know for sure is 2.6 times 10 to the 9th is D. Now I'll put a comma. This F was 2.9. The rest of them are all 10 to the 8th. So out of the 10 to the 8th, A, not B, let me erase B. We know that's the smallest. Let's put that as the least. B is the least because it's 10 to the 7th. By a factor of 10, it's smaller. Now we only have to order 3 more numbers. Well, we're going to look at the lead numbers. 7.2 is bigger than 7.04, and 7.04 is bigger than 3.1. So let's order those as it would be C, and then A, and then it's finally E. Now I'm missing a letter in here, and I've made an error because I've left off, F. But F is smaller than E, so we need to put right here, we're going to put F. And let's double check. That's really important. Let's go back. D is 10 to the 9th. It's definitely the biggest. B is 10 to the 7th. It's definitely the smallest. Now we have to order the other 4. And what did we do? We looked at the leading numbers. Since they're all 10 to the 8th, 10 to the 8th, 10 to the 8th, so they're all the same. Now the leading number is going to be the key here because 7.2 is larger than 7.04. So it was C, then it was A, then 3.1, which was E, and then F. So now it's correct. So take your time on your test to make sure you order them correctly. Problem 6. The radius of the Earth is approximately 4 times 10 to the 3rd miles. Miles is important. It's a unit of measure. We're talking about the radius of the Earth, the planet we live on. In contrast, the radius of the Sun, whoa, the Sun is much bigger than the Earth, is 8 times 10 to the 8th. Much, much larger by a factor of 10 to the 5th. How many times larger is the Sun than Earth? Well, what do? They want to know, compare the Sun to the Earth. They want the larger object to the smaller object, and then you can tell how many times bigger the Sun is. So the larger object is the Sun, 8 times 10 to the 8th. And the smaller, this is the Sun to the Earth. And the Earth is 4 times 10 cubed. And you end up with, okay, well, we have 8 over 4. The coefficient can be divided. The coefficient is the leading term. And then our rule says, well, so when we've introduced this, we've talked about it, this is the commutative and the associative property. We have the same base. The base is 10. And our rule says, look at the exponents, and since we're dividing, we're going to subtract 8 minus 3. So let's simplify. 8 divided by 4 is 2. And then we have 10 to the 5th. So how much bigger? it's 2 times 10 to the 5th larger. Or we could write it as 2 and move that decimal point out, add 5 zeros. It's 200,000. The sun is 200,000 times larger than Earth. Now, if somebody ever asks you how much bigger the sun is compared to the Earth, you can now tell them it's 200,000 times. Saul's calculator has 8 digits. Okay, that's important. He entered, he entered 60 million. Then he pressed the X squared key. Oh boy, he's squaring 60 million. To square 60 million. Oh, but you know, his calculator is only going to show 8 digits. So let's write this as scientific notation, which it asked for in the first case. 60 million. And we're going to move that decimal. Again, 1, 2, 3, 4, 5, 6, 7. 6 times 10 to the 7th. Now, he hit the squared button. Let's write what he did. He did 60 million. And then he squared it, right? Well, we know that 60 million is 6 times 10 to the 7th. And he squared it. What does our property of product say? It says that each term in here is going to be squared. So we're going to end up with 6. 1 times 2. We got to, if it's power to a power, we're going to multiply. I've seen some errors there. And we're going to multiply. The other thing is the 10. It was to the 7th power. And we're going to multiply it times 2 because it's being raised to the 2nd power. And we end up with 6 squared times 10. 7 times 2 is 14. Now it can go further. This is going to be 36 times 10 to the 14th. And our problem is it is no longer in scientific notation because the leading number has to be between 1 and 10. We're going to move the decimal 1 spot. And we made it smaller by a factor of 10. We need to compensate for that. We're going to add a 10 on because we've made it smaller by 10, so we need to make it larger by 10. Smaller by, we divided by 10. So we made this larger by making it by multiplying by 10. So we compensate, and that's why this added 1, and now it's in scientific notation. And now we have to explain for the very final part. Explain how you use scientific notation to find your answer in part B. So how do we first we wrote 60 million in scientific notation. Second, we squared squared our number. We squared the number, and we applied the power of a product. Property. Now these are the exact same steps virtually. Number 3, we had to rewrite in scientific notation. These are virtually the same as the notes that you took during our lessons of scientific notation in lessons 1-6, 1-7. So this concludes our review of the test study guide.
Good morning, TJ. teachers, this is a reminder, if you have morning yard duty, please report to your area at this time. Once again, if you have morning yard duty, please report to your area at this time. Thank you.